In this video, we want to start or introduce the idea of functions. And you've heard this before. You've seen functions in Algebra 1, you've seen functions in Algebra 2, you've probably even talked a little bit about them in geometry. So it's not a new idea. We just want to kind of clarify some of the things so we're all kind of using the same terminology and talking about the same thing. First off, a function is a rule that assigns to every element in the set D, the domain, exactly one element in the range R. And you may remember drawing this in the past where you drew arrows back and forth and tried to determine. We're kind of moving beyond that now that we're beyond Algebra 2. And we're just going to really concentrate on this idea of the rule. Or there's some way, there's some formula that assigns a value to another value. Now, it also has in here this domain and range. So if we're going to talk about the domain and the range, we have to understand what does that mean. Well, the domain is the set of values for where the function is defined. It's the values that work. It's what you can plug into your equation, your formula, your rule. Our range is the output. It's the numerical or whatever the function happens to be output you get from the function. Now we're used to some math examples and you've seen it before, but let's look at some non-math examples that deal with functions. The first is your student number. This is a function. Your domain here would be students in green local. Your range would be your student number. Now, as you look at this, there's a formula that determines your student number. The first two digits of your student number have to do with what year you graduate. So if your first number starts with 1-3, you're a senior. You graduate this year. If they are 1-5, you're a sophomore. You graduate in 2 years. Now, these are assigned when you start school. So obviously, if you were held back at some point, they can change. So there's a formula, there's a rule that assigns the first two digits of your student number. The second digit of your social security number, I'm going to do that next, of your student number says what elementary school you went to. If your first number was 133, you are a senior that went to Smithville Elementary. If your first three numbers are 154, you are a sophomore that went to Marshallville. So this third digit will tell you Smithville 3 or Marshallville 4. Now you may say, well, I don't have that, or you know some people that maybe have a 2. 2s can come into play when somebody moves into the district. They can come into play when somebody moves into middle school or high school. This is how they assign the numbers. Now, it's not 100%. There's been known people that slide through or somebody makes a mistake at the beginning, that there's other kinds of numbers. But most students, this is the formula for your student number. Another example, this is a social security number. All of you have a social security number. You probably don't know it right now off the top of your head, but you have a number. And if you look at your social security number, the first 3 digits of your social security number is what's called the area number. And it has to do with where you were born. Every state, as you can see here, has its own first 3 digits. So if you were in Ohio, your first 3 digits are 268 to 302. Those will be the first 3 digits of your social security number. Now, I should mention, technically, this is not where you were born. It's more to do with where your application was submitted to the government. So it's where your parents submitted the paperwork. Now, almost always, that's where you're born. Now, I do have a friend who has a child that was born in Connecticut. They were 6 weeks early. They went to Connecticut for vacation to visit some family. They had the baby 6 weeks early. Obviously, they were hoping to get back to Ohio before they had the baby. So I asked them the one time, is their social security number from Connecticut or from Ohio? And they have an Ohio number because when they came back home, they filed the paperwork and so forth. So they have, even though technically they were born in Connecticut, it's where your parents filed the paperwork. And you can see there's a few here that are not issued, 237 to 246. There's some all the way down at the end here that are not issued also. I should note that this list is old. Starting in June of 2011, they switched the procedure. It is now completely random. This is how it used to be. Nowadays, they completely randomly generate all the digits. The middle two digits, if you think of your Social Security number, your first three digits, and then you have two middle digits, are called the group number. And there's a formula for how they assign those also. They're a little more complicated. But if you knew when somebody was born, what year they were born, where they were born, you could come up with a pretty good guess as to what their first three digits were and their middle two digits. The last four were completely random. So now they've changed it, and they make the entire thing random. What this also does is it allows them to take places, let's say like Florida, where the population is booming, and they're running out of numbers, and places like, let's say North Dakota, where it's not. Now, they don't have as many numbers, but they also can use some of these where they're not issued, and so with computers, they just randomly pick them. But there's an example of a function. For our student numbers, the domain, what works, are green local students. Obviously, the formula doesn't work if you live in Worcester, and you go to Worcester, or you live in Apple Creek and you go to Wayndale. That's not in the domain. The domain is what works. Social Security number is similar. The domain is citizens of the United States. Somebody who lives in Africa doesn't have a Social Security number unless they're an American citizen. So the domain is what fits, what works in the function. Now, here's an example of how we normally think of a function. F of x is 3x minus 2. That's our formula. We want to evaluate f of 2. We substitute 2 in for x. Remember, whenever you substitute in, always put parentheses around it. It helps take care of mistakes later. And then we can evaluate this, 6 minus 2, and we get 4. One thing to understand is if we want to find the value of 3a, we still do the same thing. We just take 3a and substitute it into the function, and we get 9a minus 2. Can't simplify it, we can do that. If we wanted to say, well, what's f of Tom? We could do that. 3 times Tom minus 2. The point is, no matter how complicated, messy, or difficult this part gets, all we do is plug that in for x, or whatever our variable happens to be. So, here's the question. Is f of 2 plus 3 equal to f of 2 plus f of 3? Well, let's figure it out. What is f of 2 plus 3? Well, that would be f of 5. And if my function is 3x, that would be 3 times 5. That's 15. Now, let's find what is f of 2 and f of 3. F of 2 is 3 times 2, or 6. F of 3 is 3 times 3, which is 9. So, f of 2 plus f of 3 is 6 plus 9, which is 15. And yes, they are equal. Now, will they always be equal? No. They work for this function only. That's not always true. Understand that. That works for this function. Try another one. What about f of 2 times 3 and f of 2 times f of 3? Does that work for the same function? Well, let's find f of 2 times 3, which is f of 6. 3 times 6 is 18. f of 2 is 3 times 2, which is 6. F of 3 is 3 times 3, which is 9. And 6 times 9 is 54. So those are not equal. So no, they're not equal. Once again, depends on the function. So as you do some homework problems such as these, ask you this question for different functions, and you have to check, are they equal, by just evaluating them. Now, we looked at, some of you got to the questions on the Khan Academy last week where we looked at this. We're going to find the functional value f of 1, f of negative 1, f of 3, f of 0, f of negative 4, given the graph. And this was fairly easy once you learned how to do this. So if I wanted to find f of 1, I go to my x-coordinate to 1, and I say, well, what is the y-coordinate? 1. F of negative 1, I go to negative 1, the y-coordinate is 2. F of 3, the y-coordinate is negative 1. F of 0, the y-coordinate is 1. F of negative 4, the y-coordinate is 2. Now, if we want to look at the domain, we want to look at all the values here. Now, for example, let's just look at a side one here. If I wanted to know what is f of negative 5. Nope, let's not do that. Yep, I do want to do that. F of negative 5. Well, if you come to negative 5, which is right here, there's no functional value. It's undefined. This value of negative 5 doesn't work in this function. So it's not in our domain. So what we want to do for our domain, that's the x's. So I want to figure out what x's work. Well, they work from here, and they work to there. So what is that value? That is from negative 4 to 5. My range is my y's. My y's go from right here at negative 1 up to here at 3. So my range is negative 1, 3. That is how we can get our domain and range from the graph. Now, if we looked at this and I said, well, what is f of 1? You go to 1, I have two answers. Is it 1 or negative 1? Not sure. What about f of negative 2? Well, that's 2 and negative 2. I'm not sure. Well, if we go back to our very first slide, let's just recap here. It says the rule assigns to every element in the domain exactly 1 element in the range. So we're only allowed to have 1. This can't go to 2 different values. This is not a function. Now, you may remember talking about this previously. The way we can determine or show that it's not a function is called the vertical line test. If we take a vertical line and we pass it over our graph, if it ever intersects 2 points at the same time, not a function. This obviously intersects at a whole bunch of points. As long as there's 1. So what that means is if we have a graph like this, and say, well, okay, is that 1 to 1? And you may, that's not a very good vertical line, is it? You could say, well, over here only intersects 1. We're in good shape. Over here only intersects at 1 point. We're in good shape. But because it intersects right here at 2, this is not a function. So that's how our vertical line works, what vertical line test works. Now let's say we have this function. What would be our domain? Well, here it goes up to 3 and then stops. This it seems to go forever, to the left. Now the bigger question is what's going on here at 1? Well, if I look at that, let's think about this. What is f of 1? At 1, what is the y-coordinate? It's 3. So we have this kind of hole with this point up above. So my domain is from negative infinity to 3. Now, my range goes from 0 up to 2, but it does not include 2. It actually, we can write it this way, it jumps all the way to 3. Now, one of the questions we'll have is, does this equation define a function? Well, how do we know? Now, you may look at this and say, well, I know what that is. It's a line. Of course that does. Well, how you can determine if it defines a function is you want to solve for y. If you can solve for y, then it's a function. So here, I can solve for y. So because I can solve for y, the answer is yes. If we look at 2, and I try to solve for y, notice what I have to do is I got to take the square root of both sides. And when we take the square root of both sides, we always have to have plus or minus. Getting back to our quadratics. So when I really try to solve for y, I get y equals the square root of 1 minus 3x, or I get y equals minus the square root of 1 minus 3x. Since I get two different functions, two different equations, I don't know which one's right, this is not a function, because I can't solve it for just y. I get plus or minus, so it's not a function. Above it is. I can just solve it for y. So that's one way to determine if something is a function or not. Can you solve it for y? All right. We are ready for the homework over functions. Sub will pass that out, and then you can work in groups to work on that homework. We're not done. We have a couple more things to do today, so we'll give you about 15, 20 minutes, and then we'll come back and move on.